In this video, we will find the number of integers less than n and relatively prime to n. And we'll also find the number of numbers not divisible by primes in a given number. So first we'll find the number of integers less than 480 and relatively prime to 480. This is actually the Euler's phi function of 480, phi of 480. So that is what we are asked to compute. So you consider 480 and we know how to write that as product of prime powers. So you have 480 being written as 2 power 5 into 3 into 5. So we know that the formula to compute Euler's phi function is this. You have to write that number n and then that into 1 minus 1 by first prime, in the same way 1 minus 1 by second prime into 1 minus 1 by third prime and so on. So here the primes are 2, 3, 5. So you have 1 minus half, 1 minus 1 by 3, 1 minus 1 by 5, and the entire number is to be written here. So this on simplification gives you 1 minus half, half, 1 minus 1 by 3, 3 minus 1 by 3, that is 2 by 3, 5 minus 1, that's 4 by 5 you have. So cancelling out 3 and 5, and here 2 power 5, 2, so you get 2 power 4. So that gives us, from here 2 and 4 will be left, So 3, 5 we have cancelled and 1, 2 we have cancelled. So 2 power 4, here 2 and 4 are left. So if you consider the product, we get it as 128. So next is find the number of integers less than 21 and relatively prime to 21. Now in this case, this 21 is written as 3 into 7, and we can make use of this result, which states that if n is a, b, the product, in which the numbers are relatively prime, then phi of n can be written as phi of a into phi of b. What is n? N is a into b. So here 21 is written as 3 into 7, 3 and 7 are relatively prime. So we can write this as phi of 3 into phi of 7. But 3 being a prime number, phi of 3 is 3 minus 1. 7 being a prime number, phi of 7 is 7 minus 1, that is 6. So 2 into 6, that gives us 12. So the number of integers less than 21 and relatively prime to 21, you have that to be 12. So in the next one, we are going to find the number of numbers not divisible by these primes 2, 3, 5 in 100. So we shall take n to be 100, and let a1 denote the set of all numbers divisible by 2 in 100. And in the same way, a2, let it denote the numbers, the set of all numbers divisible by 3 in 100, and a3, let it denote the set of all numbers divisible by 5 in 100. Now, how to compute the order of this a1, that is the number of numbers divisible by 2 in 100 is given by this floor function 100 by 2. And in the same way for 3 it is 100, the floor function of 100 by 3, and in the same way here the number of numbers divisible by 5, and this is given by this floor function 100 by 5. So this on computation gives you 50, 33 and 20. So now we are going to find this the set of all numbers in n divisible by 2 and 3. The same way the set of numbers in n divisible by 3 and 5, and the numbers in n, the set of all numbers in n divisible by 5 and 2. We'll name them as a1 intersection a2, a2 intersection a3, a3 intersection a1. Already we have mentioned a1, a2, a3 stands for what. So if you want to find the number of numbers in n divisible by 2 and 3, again that is given by this floor function whose value is 16. And similarly for this, it is given by this floor function and the answer for that is 6. So the number of numbers in this collection is 16. Similarly, in this it is 6, and in this it is 10. Now we want to compute the number of numbers in n divisible by 2, 3 and 5. So that is given by the number of numbers by this formula, flow function of this, and that is nothing but this 3, the number 3. Now, by inclusion exclusion principle, the number of numbers divisible by 2, 3 and 5, that is given by this, the order of, or the number of elements present in the union. But the order of this is given by order of A1 plus order of A2 plus order of A3 minus order of A1 intersection A2, then A2 intersection A3 plus order of A3 intersection A1. Then we have this to be minus of, we have, so you have this to be plus the number of numbers in this that we have. So you have already this to be 50, 33, 20, and that is 103. So if we have the sum of all this, it is 103, and when we consider this, it is 16 plus 6 plus 10, so you have 32, and the last one we have 3, so you have this. So this gives us 74. But these are the numbers which are divisible by 2, 3 and 5. Our job is to find the number of numbers not divisible by these numbers. So the number of numbers not divisible by 3 is, n is given by 100. So that minus this one gives 100 minus 74 gives 26. So there are 26 numbers that are not divisible by 2, 3, 5 in 100. So this is how, even if you change the, see, suppose I am given some other number here, say 1000, and in that 2, 3, 5, the same procedure is adopted, and from which you'll get the number of numbers not divisible by the prime numbers, whatever that's given the problem, that can be used here to get the corresponding answer. Thank you.